Good evening, and we're continuing from the Sheraton Los Angeles Airport at 6101 West Century Boulevard. I'm here on the 11th floor. I'm on the topic, the amazing 5x12 matrix. Dolphy A. Gilpin, that is Dolphy Alexander Gilpin, is the name, your instructor. And in previous session, I've generated the economic outputs, SLS DLS, in parts. And I've also started on some circuit analysis, but my circuits were abstract. Now I'm going to design some circuit. I'm going to do it from my head, make up this circuitry with some very simple values so that our calculation of the determinants would be much simpler. And so then suppose if we have now, say, a 3x3 mesh circuit looking like so. And say suppose if I'm drawing some small voltage values, in previous time I've used large voltage, say 480, 960, or as we have seen operating elevators, and just going to use some relatively small voltage here now, say 5 volts. I want to use some small resistances to, say, 2 ohms, 3 ohms, 4 ohms, 5 ohms, 1 ohms. And this could be just one form of a 3x3 mesh, in which this is mesh 1 with a corresponding current I1. This is mesh 2, we call it M2, M1. And this will be like M3 with a corresponding current I3. You could have similarly drawn it like this. Could be another form of 3x3 circuitry. One, two, three, 1 ohms. All right, let's start off with this one. And we say now that suppose this voltage was 10 volts, and this one was 5 volts. We say now that delta will equal to the determinant of, and we're going to now put in the elements by infection. So R11 would be the resistance in mesh 1. And if we add the resistances, we get 4 and 2, 6 ohms. R11. R1 and 2, mesh 1 and 2, and the only resistances corresponding to mesh 1 and 2 would be here 4. And it takes on negative 4 ohms. Neutral resistances are negative. R13 resistances in mesh 1 and mesh 3, this is mesh 3 here now. That would be zero ohms. There is no resistance common to mesh 1 and 3. R2 and 1, resistance in mesh 2, mesh 1, which will be 4 ohms, takes on a negative. R2 and 2, resistance common in mesh 2 alone, will be 3 and 1, 4. And 4, 8 ohms. And R2, 3, resistance common in mesh 2 and mesh 3 will be 0. R31, resistance common in mesh 3 and mesh 1, it's only, that's 0 as well. R32, resistance common in mesh 3 and mesh 2, we notice here is the common line here, it's 0. And R33 would be 5 ohms, 5 ohms. So here we have put in the value of the resistance is by inspection, and this calculation will be easy due to the small elements value and the zeros that are in it as well. And so if you make the calculation for this, and suppose now we calculate the voltage in V1, in mesh 1, as V1 now, M1V equals V1, and that's equal to 5 volts, negative to positive, and this is positive to negative, so this will be minus. So 5 minus 10 will be minus 5 volts. The voltage for mesh 2 would be negative to positive, 10 volts. V2 equals 10 volts. And V3, voltage in mesh 3 here would be 0. So what we have here now is that using V equals Ri, we have now that minus 5, 10, and 0, which is the V equals to 6 minus 4, 0, minus 4, 8, 0, 0, 0, 5, and I1, I2, and I3, which are the unknowns. And so we say now that I1 would be equals to N I11 over delta. I2 will be equals to N I22 over delta. And I3 equals to N I33 over delta. I will take a break here, and when we come back, we'll actually do the calculation of this, since it's a very easy determinant to calculate.